Thank you for taking the time to take a look at our computer-aided design project for a drone. The CAD Tricopter is a state-of-the-art remote control drone capable of providing high-quality control of area maneuverability, all the while maintaining a stylish and boastful presentation. As you can see, the inspiration for the design strays away from the typical approach of a four-motor quadcopter. The tricopter makes use of three propellers. These propellers are arranged in a semicircular fashion. The inspiration for this design was simply a desire to emphasize the stability and trinity of a triangle while combining the geometric unity and perfection of a circle. Simply put, the design is intended to capture the eyes of an audience looking for something more than just a bulky combination of motors and axles. Its curvy design features gives a sci-fi feel that appeals to people looking for something a bit different than the usual. So let's talk a little bit about the features. If you take a look at the bottom of the drone, you can see that the drone has a camera port. This is the main feature of this drone, aside from the fact that it operates with three propellers. The camera port is a 40 by 8 millimeter port that houses an onboard HD camera that comes with the drone. The port is attached to the base of the head, which is able to rotate at the command of the user. So you can see that this section here, this cylindrical section here, is able to rotate a full 360 degrees, and the camera is to be placed in this spacing over here. We can also take a look at the guards of the drone. Now, these propeller guards are designed to be very sturdy and stable so that the propellers housed inside of the guards will be protected from, let's say, and oncoming obstacles, or maybe if the drone is to be flying through a wooded area, it'll protect it from hitting or getting disturbed by trees and leaves and branches. Now, the design of the drone is such that we've been very specific with the dimensioning and the tolerance of the various different parts because uh, as any designer would like to have, all these parts are to fit together very snugly and very comfortably so that the drone is very stable and sturdy during flight. So to begin with, the major parts of the drone, such as the head, the outer ring, the arms, and the tail, are connected together with a transitional fit of H7/N6. This fit allows these major parts to fit snugly together, but still allows an easy disassembly of the drone for the user. The motors and propeller blades, on the other hand, are connected with a force fit of H7/U6. This will allow the propeller blades to remain tightly fitted on the motor during high-speed revolutions and operation of the drone. So let's take a look at the arm of the drone. So these arms over here are what you see connected here. The two arms of the drone spanning out from the sides of the head are each 140 millimeters in length and 10 millimeters in thickness. The edges of the arms are rounded with a radius of 5 millimeters. This is to allow an easy feel of touch when holding the drone. The hole near the tip has a diameter of 20 millimeters with a tolerance of 20.008 to 20.021 millimeters. This is where the motor is to be fitted. The tip of the arm rounds at a radius of 15 millimeters. As you can see, the beginning of the arm has a smaller extension. This extension has a length of 10 millimeters with a tolerance of 10.01 to 10.02 millimeters. And this allows the arm to fit to the head of the drone. So this small shaft from behind the arm here is what allows the arm to fit properly to the head of the drone. So as you can see, the tail of the drone has very similar dimensions to the arm. The only difference between the tail and the arm is that the beginning of the tail has a width of 33.18 millimeters, whereas the beginning of the arm has a width of 30 uh, millimeters. Now, for the head of the drone, we decided to go with a more sci-fi approach rather than having a bulky type of design for the head. We wanted a smooth, curvy kind of design that would be more appealing to the user. Now, the three holes on the sides of the drone on the sides of the drone head measure at a depth of 10 millimeters with a tolerance of 10.00 to 10.015 millimeters. This is to allow the shaft extension of the arm to fit comfortably. These are the three holes on the sides of the head, and these are where the shaft extension from the drone arms and tail are to fit into. Here we have the outer ring for the drone. Now, this outer ring consists of three propeller guards, as mentioned before. The centers of these three propeller guards are arranged in a way to lie on a circle of diameter 500 millimeters. Now, each guard has an inner diameter of 180 millimeters and an outer diameter of 200 millimeters. The thickness the thickness of the outer ring of the drone is 30 millimeters. Now, this here is the motor for the drone, and the base of the motor has a diameter of 20 millimeters with an upper tolerance limit of 20.028 millimeters and a lower limit of 20.015 millimeters. The full height of the motor is 30 millimeters, where the base has a height of 20 millimeters and the top part of the motor has a height of 10 millimeters. Now, the legs for the drone are designed to be conical in shape with a parabolic cross section. The height is 80 millimeters tall, and the top surface of the leg has a hole with diameter 20 millimeters and a tolerance of 20.000 to 20.021 millimeters. The depth of this hole is 10 millimeters, and this is where the base of the motor is to fit. So here we have the propeller blades. Each blade spans out at 75 millimeters. So once again, this is our CAD Tricopter project, and thank you very much for your time.